Hello, I myself Professor M. N. Jadhav from Kekewak Polytechnic, Nasik. Today, we'll learn the study of different types of negative feedback amplifiers. First, we want to clarify what is the concept of feedback. The feedback is nothing but the process of injecting the fractions of the output energy to the input side. And depending whether the feedback signal is going to add or it is going to oppose the input signal, they are classified in two types. First as a positive feedback and second as a negative feedback. In positive feedback, the feedback, which may be the voltage or the current, it is in phase with the input signals and thus it get added with the input signal and it's called as a positive feedback. In this, the phase shift is of 360 degree. And second type, negative feedback. In negative feedback, the output voltage or the current, it may be out of phase with the input signal. So it opposes the input signal, is called as a negative feedback circuits. There are further the subtypes of the negative feedback which are listed as negative voltage feedback and second as negative current feedback circuits. Again, this negative voltage feedback is further classified as voltage series feedback and voltage shunt feedback circuits, while the negative current feedback circuits is classified as current series feedback and current shunt feedback circuits. Now we will study in detail each type, that is what is voltage series feedback, what is voltage shunt feedback, what is current series and what is current shunt feedback circuits. So here this figure indicates the connections for voltage series feedback. In this, the fraction of the output voltage is applied in series with the input voltage through the feedback circuits. This type of circuits are also called as shunt-driven series feedback connections, or the other name as a parallel series circuits. When we are going to make these applications in this way, at that time, the output impedance is going to decrease and the input impedance of the circuit is going to increase. In second type, that is voltage shunt feedback connections, the fraction of the output voltage is applied in parallel with the input voltage through the feedback network as shown in the figure. Sometimes this circuit we are also going to call as the shunt driven or shunt feedback circuits or parallel prototype circuits. Because of these connections in this way, the output impedance and the input impedance of the circuit is going to decrease. So this particular block diagram is indicates the voltage shunt feedback connections. Now this diagram indicates the current series feedback connections. In these particular circuits, the output voltage is applied in series with the input voltage through the feedback circuits as shown in the figure. These circuits sometimes also called as series driven series feedback circuits or series circuits. And with the help of these circuits, the output impedance and the input impedance of the circuit is going to increase. So the connections indicates the series current feedback network. And the last method for negative feedback is that current shunt feedback connections. As the name indicates, the fractions of the output voltage is applied in series with the input voltage through the feedback circuits. And sometimes the circuits are also called as series driven shunt feedback connections or a series parallel circuits. With the help of these connections in the circuits, the output impedance is increased and the input impedance is going to decrease. So diagram is related to your current shunt feedback connections. Now here we learned all these four types of negative feedback connections. Here there is a comparison between all these negative feedback amplifier connected circuits. First we will see, considering the different parameters, the different comparison points are there. We are considering here the parameters, that is voltage gain, bandwidth, input resistance, output resistance, and the harmonic distortions along with the noise present in those. This is the comparison points for all the negative feedback amplifier connections. So here the voltage gain for voltage series decreases. For voltage shunt, it is going to decrease. Current series, it is decrease, and the current shunt, it is going to decrease. Just like the other points are here. Thank you.